Hello and welcome to another lecture of the course Aquaculture. Today we are going to talk about, in continuation to my previous lecture, about analysis of water quality parameters for aquaculture in part 2, the remaining parameters what we discussed in our previous lecture. In previous lecture, if you remember, we discussed about the water quality in general, the importance of water quality in aquaculture, whether you are going for freshwater aquaculture, brackish-water aquaculture, or mariculture. I showed you the range of different water quality parameters in the range which is required for aquaculture. Then we also discussed little bit details of temperature and then dissolved oxygen and pH. Now, today we are going to start with the parameter alkalinity. As if you remember, uh, during my talk on pH, I told you that fishes prefer little alkaline range in water. So that way alkalinity becomes very important. That means you will have to take into account that what is the alkalinity of your water. If it is not having enough alkalinity required for the fish growth, survival, growth, reproduction, every aspect I'm talking, then you will have to take appropriate measures for that. So, what is alkalinity? In fact, first you must have studied it. Alkalinity is a measurement of carbonates and bicarbonate ions which are dissolved in water. So, the carbonate and bicarbonate ions which are dissolved in water, we measure that, and that is represented as alkalinity. The amount of carbon dioxide fluctuates, the pH of water changes. We have studied that in the previous lecture. The magnitude of this shift is determined by the water's buffering capacity. In fact, the alkalinity of the water system that provides the water the cushion to absorb acids and bases or fluctuations in pH. So that works as a cushion to take control the fluctuations in the pH, and the fishes are not that much affected. A suitable range of alkalinity is 20 to 300 ppm. Alkalinity in excess of 300 ppm usually does not adversely affect, but when it goes beyond 300 ppm, then there are many aspects. If you go into finer details of studying their life cycle at one or the other stages, this may have adverse impact on its life cycle. If you are going for short-term culture, you may not notice that, but if you are going to have a long-term culture, or getting them breed and other things, then it will have its own impact. But in short-term culture practice, putting the seed and harvesting it after a few months, that will be a different story. Now, how we go for alkalinity measurement? As you must have studied in the laboratories, we take water sample, and using phenolphthalein indicator, we analyze alkalinity. And if the solution remains colorless, then we consider phenolphthalein alkalinity as 0. If the color changes to pink after addition of phenolphthalein, then titrated with 0.1 normal HCl, NaCl, until the color disappears at endpoint. And this endpoint indicates the phenolphthalein alkalinity. Now add 2 to 3 drops of methyl orange to the same sample and continue the titration further until the yellow color changes to pink at the endpoint. This is total alkalinity. Phenolphthalein alkalinity and total alkalinity can be measured in the same titration in 2 steps. So you get information about the carbonates and bicarbonates present in the system in a better manner. Now, what is phenolphthalein alkalinity and what is total alkalinity? A rough idea I can give you. Phenolphthalein alkalinity measures hydroxides and half of the carbonates at a pH of 8.3. And Total alkalinity measures all the carbonates, bicarbonates, and hydroxide alkalinity at a pH of around 4.5. So you get information of alkalinity, whether total alkalinity or phenolphthalein alkalinity. Usually we go for total alkalinity, and that gives you a better understanding of how to keep these parameters in check. These are the equations used for calculating the alkalinity as calcium carbonate, mg per liter or ppm. Then comes water hardness. Calcium and magnesium ions comprise hardness, and the test procedures usually determine both ions as total hardness, expressed as ppm calcium carbonate. So, in most waters, the concentrations of alkalinity and hardness are similar, but they can differ vastly as alkalinity measures negative ions, carbonate and bicarbonate, and hardness measures positive ions. So, that way, alkalinity and hardness may show variations depending on what kind of these negative ions or positive ions are prevalent in those regions. Hardness is important, especially in the culture of several commercial species, as striped bass and catfish. If hardness is deficient, these species not grow well. Hardness should be above 50 ppm. Low hardness can be adjusted by the addition of calcium chloride or lime. So, hardness is very important. We all know that up to a certain limit again. And how it is important, I can explain you. For example, when you are going for induced breeding, when the fishes release eggs, they are fertilized. Then these fertilized eggs are kept as such in the water for the process we call as water hardening. During that hardening process, that is very important for the embryonic growth. That water hardening process requires certain levels of hardness, especially the presence of calcium. So, if the hardness is not within the optimal range, the embryonic development of the fishes will be affected. If they go beyond a limit or below a limit, both are going to influence adversely especially the embryonic development of the fishes. And of course, we know that we have already discussed about alkalinity, pH, and other aspects that fishes live in slightly alkaline conditions. So, if these hardness is better, hardness is more, then there may be chances of more alkalinity. So, they show, there is certain preferred range in which we should maintain the hardness as well. Depending on which system we are going, for freshwater systems, of course, the hardness alkalinity levels will be very different than those in the brackish waters or those in the mariculture. So, you should always go for specific requirements in the type of culture systems or type of culture species that you are targeting, and then maintain the water quality parameters within those described optimal ranges. So, again, here what we do in laboratory, we take water sample, and then 1 ml of buffer solution is added, and then indicator, and we get the data and calculate the hardness as milligram per liter or ppm calcium carbonate that can be utilized for describing the water quality parameter in any of the culture practice. Now, free carbon dioxide. Only when using groundwater, transporting fish at high densities, or in recirculatory systems are carbon dioxide problems likely to develop. When the supply of dissolved oxygen may become limiting, then free carbon dioxide conditions you may experience. In the intensive culture operation, since you are doing supplementing oxygen from outside, the problem may not occur if everything is going fine. In semi-intensive aquaculture system, I have explained it earlier also, if there are cloudy conditions, the phytoplankton present in the system, they are not getting enough light for photosynthesis, then you may get more and more free carbon dioxide condition, and that may adversely impact the entire culture system. At high concentrations, carbon dioxide causes fish to lose equilibrium, become disoriented, and sometimes die. Testing groundwaters before and aerating it, if necessary, will reduce carbon dioxide. What happens? You must have seen that in many hatcheries and many fish farms, what they do when they are going to supply, especially in the hatcheries, when if they are using the groundwater or even canal water, then the water is first conditioned. Water is first conditioned and then it is aerated. After aerating, it is supplied to the hatchery. So when the dissolved oxygen is sufficient, or some places I have also seen that in the conditioning pond, how they fill water, they are pouring water from a particular height. Maybe in some places I have seen they sometimes fit showers also, so getting more atmospheric oxygen dissolved. So by just the purpose is only increasing the dissolved oxygen content and lowering the free carbon dioxide content, and then you can use that thing for supplying to the fish. Careful monitoring, aeration, oxygenation, and buffering of water will keep carbon dioxide at acceptable levels. This is how we go for very simple methods in lab to measure free carbon dioxide, but very important parameter to understand. This is a kind of warning that you have to take care of your pond water quality. Then ammonia, again very important parameter. Most fish and freshwater invertebrates excrete ammonia as their principal nitrogenous waste. Proportion of ammonia varies with pH and temperature. Now, with the level of pH and the temperature variation, ammonia may increase. Here it has been written as pH and temperature increase. When pH increase, the amount of ammonia in the toxic form increases. But of course, within a limited range, it will not affect. But if it goes beyond a range, then it is going to adversely impact the system. Fish continuously exposed to more than 0.02 ppm of the ammonia may exhibit reduced growth and increased susceptibility to disease. The problem with these water quality parameters is that if they go beyond the defined limit, then they affect not only the growth rate of the organism of the fish, but they also cause disease in the fish. When fish cultured intensively, fed protein-rich feeds, they can produce high concentrations of ammonia. And when you are intensifying the practice, that means you are providing more food. If you want good quality fish in terms of flesh quality, then you have to feed them nutritionally balanced and protein-rich diet. So you are putting in more feed and protein-rich food, which is rich in nitrogen, then ultimately you are putting more organic load in the system, and that will ultimately result in production of more ammonia in the water. Ammonia, however, is naturally removed by bacteria that initially convert it into nitrite and subsequently into nitrate. If nitrite is more, then it is toxic and causes brown blood disease in case of fishes. Removal or detoxification of ammonia is facilitated by providing and maintaining an optimal environment, where some appropriate microbes can develop and they can detoxify the excess ammonia which is present in the water and make it better for the fish again. Now, another water quality parameter, very simple parameter. If you are observing it, you can have many, especially if you are doing semi-intensive culture. As I told you that for many Indian major crops, people are still doing semi-intensive culture and they are contributing greatly to the total overall fish production of the country. Transparency or light penetration or water clarity, we often call. Water clarity can affect, or transparency can affect fish growth. How it can? There are certain fishes which may prefer to live in slightly turbid waters. That the reason for that turbidity may be different. Now, there are certain fishes which prefer to live in a very clean water. When the water is turbid, that means it may be having little less oxygen, or sometimes because of some pollutants also, or contaminants. Catfishes or any other fish which is having accessory breathing organ, they may prefer to live in these conditions. But fishes which require high oxygen, which show great growth performance at high oxygen levels, for example, trouts, carps, they need clean water having high transparency. But if you are going for semi-intensive culture, then little turbidity is required, and that turbidity should be because of the presence of plankton. So if that turbidity is because of the presence of plankton, the fishes may get more natural food, and they may show better growth rate, and they show little dependency on supplemented food from outside. So accumulation of suspended solids and discoloration of culture water occur in the recirculating system, which can cause stress to fish and make them prone to diseases. Because if especially if you are going in recirculatory systems, and if you are going for intensive culture, then you will have to be very careful. There should be no turbidity beyond an acceptable limit. In intensive culture system, everything should be maintained to optimal conditions as much as possible. That is very necessary, because in semi-intensive system you are having an earthen pond, so the nature itself takes care of many things. So many of the things you may not notice, but nature takes care with time. But here in the intensive culture practice, where we use usually tanks of different materials, so and we are stocking large number of fishes, so you will have to take care of their requirement, which can hamper their survival, growth, and other aspects of their life. We use Sakai disk to measure the transparency of water, and then calculate the transparency using this simple equipment. But you just keep on dipping it, and until it disappears, then you can measure the distance. Now, we have so far discussed few important water quality parameters that can have a strong influence on the performance of aquaculture system as a whole. It's not necessary that you are having all the facilities to analyze all the water quality parameters at your place. You are not supposed to do that. What you should know how to utilize the information on those water quality parameters, how to utilize the data which you may be having on these water quality parameters in order to manage your aquaculture farm very effectively in a very scientific manner, so that the economic viability, the sustainability of aquaculture practice can be ensured. That is the thing that we are here focusing to. So there are a large number of agencies which analyze the water and soil quality, and government agencies I am talking. There are many private agencies as well, but there are many government agencies which can do the job very effectively and in a very accountable manner, you can say, at many places. Here, if you visit the NFDB website, if you remember, I told you regarding NFDB in quite detail in one of my lectures. If you visit the website of National Fisheries Development Board, which is contributing significantly in the growth of aquaculture and fisheries sector in the country, they have given a list of testing cost of various parameters, testing cost of sequencing samples, and many other things. Hands-on training they are also providing, and the places where you can visit for testing your samples, how you can send your samples, and very almost details about many of the parameters which are required, which are necessary for aquaculture. You can visit the website and you will get the information on the same, and then you can act accordingly. But please be assured that you have to take care of water quality parameters first, then proceed further. It's not only NFDB, as I told you. I have given here only few websites. I have shown here only few websites, a screenshot, but you can visit websites of any National Fisheries Institute, any KVK, any maybe if you are able to access the facilities of any academic and research institutions near you, and you can get your analyzer. I mean, that is not a problem if you are willing to get the samples analyzed. One way or the other, you can approach to state fisheries department officials, which are there in every district of the country, and their representatives are even at block levels also. They have to get information on the fish farmers and all. So if you approach the correct person, you can get your samples analyzed very easily. So CIFA, I told you regarding this institute also, Central Institute of Freshwater Aquaculture, that again plays very important role. You just visit the websites of any of the institutes that I have explained you earlier, and if you approach them for your problem, that okay, I am going to start aquaculture in this region, I am going to construct a pond like this, and I am going to have water source from this. Everything you will have to explain and then provide the water sample. They will not only do the job by analyzing the water sample and giving you the data, but they will interpret the data also, that what does it mean, what you should do, how you should proceed, so that you can have information. And I showed you one more, Tamil Nadu Agriculture University. I talked about this. Now we are having in Tamil Nadu, we are having one fisheries university also, that I showed you in my earlier lecture. So agriculture universities, fisheries universities, even in traditional universities, if you get access to the laboratory facilities, and that depends on the type of institution you are visiting, and if they are having resources to extend to your service. So that depends on these conditions, but you can get your samples analyzed by visiting such centers. Even these Krishi Vigyan Kendras are distributed across the country, and they have this facility that they, in fact, in a very small place called Eta in Uttar Pradesh, they have soil and water testing services also. If you will visit the services of these agencies, they have this facility. They have to do it. You visit them, you talk to them, provide your sample, you will get the data. Then Krishi Vigyan Kendra I showed you one. This is another example in Kolkata. Here again, you can have soil and water testing services for any purpose, for agriculture or for aquaculture. That depends on your purpose. Then list of laboratories in different states of India that is being provided by NFTB. I showed this NFTB website a screenshot earlier also in previous slides. There are, as I told you, there are large number of laboratories. It's not only these laboratories. If you, the first thing what you can do, visit to the state fisheries department officials, talk to them. They may suggest you some better way to get your samples analyzed in some nearby area and get the data, and then get it interpreted by the support of these officials. There are a large number of laboratories that are there, and not only that, you are having all this, but you can have, if you are very enthusiastic person, if you wish to do everything on your own, then have some automatic water analysis kit. And major water quality parameters you can analyze at the pond itself. And I have seen fish farmers, very progressive fish farmers, who got not only water analysis kit at their farm, They had their own mini library. They uh, had the provision of preparing feed at the farm, and everything they were controlling in such a better way that the profitability of the aquaculture system that becomes more, and you get involved more and more if you are learning from every step you are doing for running the aquaculture practice. So that's all in this lecture of uh, analysis of water quality for aquaculture, and mm, we will discuss some other topic in next lecture. Thank you so much.